Alright, so this is redo of the FRQ video. This area and volume. It's actually the first question of the FRQ notebook. So let's get into it. So right here it says let R be the shaded region bounded by the graph y equals ln of x and the line y equals ln 2 as shown above. Alright, let's get into part A. So part A, find the area of R. So as we can see right here, to find the area of R, we need to set up an integral of top minus bottom. And for your limits, so this is how it's gonna look. And in order to find your limits, you need to go put these to graph it. And then you put graph, and then you have to find the intersections. So we would do enter. So we get 3.1461, which you get right here. And then 1.461. Now we find the other intersection. Move it all the way to the left. Alright, now we have our new intersections, 0.1585 and negative 1.8414. Alright, now since we have our limits, we can tell that y ln x is the top function and that y equals x minus 2 is the bottom function. So we write that out and we put that into our calculator and we get dx equals 1.949. And then for part B, what we have to do, just read part B real quick. Find the value of the solid generator when R is rotated about the horizontal line y equals negative 3. Alright, so with this, there's gonna be another horizontal line, but we're still trying to find the terms of x. So for this, we need a constant, which is pi, and it's still an integral, but it's outer radius versus inner radius. So we're still using the same limits as above that we used in part A. We're still using the same limits. So once you use the same limits, the outer radius is y equals ln of x, and our lower radius is y equals x minus 2. So when you plug that in, this is what you should get. And when you put in your calculator, you should get 34.199. And then for part C, it says write but do not evaluate an integral expansion that can be used to find the value of the solid generated when R is rotated about the y-axis. Alright, so right here we're gonna have to change our functions in terms of y instead of terms of x. And for this, we can just go ahead what we're looking for value and rotate about the y-axis. So the first thing we have to do is adjust our limits, which these are our limits right now that we have been using. So now our former values of a and b are 0.1586 and 3.1462. Now we can go in using one of the functions that are given in the problem, but I'm gonna use a simpler one, which is y equals x minus 2. And we plug in our values of x's, and we're gonna get our values of y, which are new limits. So the new is going to be a negative 1.8414. When you plug in b, we're gonna get 1.462. So now we can go ahead and move on to our changing functions in terms of y. We have y equals natural logarithm of x, which we just get excuse me. So we just get e to the y power. And then for our second, we do y equals x minus 2. So all we're gonna do here now is flip this. We get x equals y plus 2. So now I have our functions, we can go ahead and set up our integral of our immigrant to solve for this volume. So the volume is going to be constant of pi, right? And then our new limits are negative. As we got our new limits right here, we just plug them in, still a and b. Okay. And now our outer radius is going to be our rightmost function, which is x minus 2, but now it's in terms of y. So it's y plus 2. So it's y2 squared. Since that is our outer radius, and we subtract our inner radius, which is represented now by x equals e to the y. So we write e to the y, this is squared, as well as now it's in terms of y. So our integral expression is that we'll find the value of the solid generated when it's all rotated of the y-axis. And now we have fully answered the first question, as we don't have to find the actual solution, we just have to find an equation to solve it. I hope this gets credit. Have a good day, Mr. Dabo.